Hello and welcome to 6.2 volume method with shells. So in short we call this the shell method. In general we use what we call the shell. The shell is typically, you could think of if you're revolving around a vertical line, and if you're taking some curve, and you're going to take that curve and start to figure out what would be the volume if we took this chunk of the curve and we spun it around some vertical axis. What we end up doing is we take these cylinders, these hollow cylinders, and we end up trying to figure out what would be the sum of all the volumes of these cylinders. So let's see if we could. So if we look at the shell is basically going to be something like, you'll have this little shell here, it'll get spun around, so you're getting this hollow, be a cylinder, best way to put it, right? It'll be a cylinder with a hole in the middle. And then for like the next one after that, you would take like another width, and then that would go around that way. And this would continue until you filled up the whole width of that interval. Okay, so you see how as we're going around here, this is going to be a circle, right? As we're going around, this is going to be like the circumference. So you'll notice some elements of the circumference formula of a circle in here. Circumference formula, we called it 2 pi r, right? So we have 2 pi, the shell radius. So a lot of times if you're doing this, it's with respect to x. So a lot of times if the shape is right up against the axis, that radius will be x. If it's a little bit farther away from the axis, then you're going to add whatever number units away. For example, if this were 1 unit away, then I would say my radius is going to be x plus 1. Okay, that would be the radius. And then the shell height we would get from the function itself. That would be the function. The function gives us the height of each of these shells. Okay, so typically radius is x, or it's x plus 1 if it's 1 unit, if the one bound is 1 unit away from the axis, that'll be x plus 1. And then the shell height, that would be given by our f of x. Okay, but this is the basic formula for it. Okay, the integral from a to b, 2 pi r times the height with respect to x. So let's take a look at our first example. Region enclosed by the x-axis and the parabola 3x minus x squared is revolved about the vertical line x equals -1 to generate a solid. Find the volume of the solid. So I'd put the descriptions here, and I wanted to include a graphic to show you guys what this will be creating. Okay, so we have the parabola, so it's this shape. We're going to spin this around. It'll create something like this, like a bundt pan. For those of you that like bundt cake, I have those special pans that create that with the hole in the middle. This is what it would look like. So if we go to set this up, our volume will be. Now, the region is from 0 to 3, right? So we have 0 to 3. Okay, so we'll have integral 0 to 3, 2 pi. Now, as I told you guys before, the radius is going to be, it's 1 unit away from our axis, right? We're spinning about x equals -1. So our radius is going to be x plus 1. And then our function is 3x minus x squared. That's our height with respect to x. Okay, so we could simplify this. The 2 pi I'm going to bring outside. And for these, we're going to FOIL this out, right? You could do a FOIL on this. So we have x times 3x would be 3x squared. X times negative x squared will be negative x cubed. 1 times 3x is 3x. And 1 times negative x squared will be negative x squared. Okay, so when we combine like terms, three x squared minus x squared, that would be 2x squared minus x cubed plus 3x. Okay, so now we could integrate this. So we have x squared becomes x cubed divided by 3, so we have 2/3 x cubed minus 1/4 x to the 4th plus 3/2 x squared. And we're going to evaluate over 3 and 0. Okay, so let's plug in. So we have 2 pi, 2/3 of 3 cubed minus 1/4 of 3 to the 4th plus 3/2 of 3 squared minus, and now we plug in the 0, 2/3 of 0 cubed minus 1/4 of 0 to the 4th plus 3/2 of 0 squared. Okay, well that second half, they're all zeros raised to powers, so that's all 0, so we don't have to worry about that. So now it's only the first part. Okay, so we got the 2 pi, 3 cubed is 27, so 2/3 of 27 minus 1/4 of 3 to the 4th would be 81 plus 3/2 of 9. Okay, so next, if we cross cancel between the 3 and 27, divided by 3 is 1, 27 divided by 3 is 9, so we have 2 times 9 is 18. Minus 81 over 4 plus 3 times 9 is 27, 27 over 2. Okay, so it looks like 4 will be the common denominator. So we have 18 over 1, that would be 36, 72 over 4 minus 81 over 4 plus 54 over 4. Okay, so we have 72 minus 81, that would be negative 9. Plus 54, that would be 45. So we have 2 pi times 45 over 4. We can cross cancel between the 2 and the 4. So that means we end up with 45 pi over 2. And that would be the final answer. Let's take a look at our next problem. The region bound by the curve y equals square root of x, x-axis, and the line x equals 4 is revolved about the y-axis to generate a solid. Find the volume of the solid. Okay, so we got the square root of x, which is our half parabola. X equals 4. So there's x equals 4. Bounded by the curve, the x-axis, and the line. So it's that, right, this shape. And we're going to spin it about the y-axis. So I'm going to spin it around the y-axis. So that means when we set up the integral, this will be from 0 to 4, 2 pi. Now we're right up against the axis, so our radius will be x. Our function would be the square root of x, that's the height. And we have dx. Okay, so we could put the 2 pi outside the integral. The x and the square root of x we could combine. This is x to the 1/2. And for x we could say that's x to the 2/2. So when we multiply we could add and we get x to the 3/2. Okay, so we can integrate that easily. So we have 2 pi. And then we have add 1 to this, so that means we would add 2 over 2. So that would be 5/2. Divide by 5/2, which is 2/5, times x to the 5/2. And then we would plug in 4. So we have 2 pi times 2/5 of 4 to the 5/2 minus 2/5 of 0 to the 5/2. Okay, so the second part, 0 to the 5/2, is 0, so that's gone. Now for the beginning part, the 4, the 2 means we're going to do square root of 4. Square root of 4 is 2. 2 to the 5th is 32. So we have 2/5 times 32 times 2 pi. Okay, so what does that mean? We have 32 times 2 is 64. 64 times 2 is 128. So we have 128 pi over 5. And that would be the final answer. Okay. Let's take a look at our next problem. The region bounded by the curve y equals square root of x, the x-axis, and the line x equals 4 is revolved about the x-axis to generate a solid. Okay, so slight change now. Okay, so if it's about the x-axis, then remember the examples up to now we did around the vertical axis or y-axis. Now when it's revolved about the x-axis, we switch gears. We do everything in terms of y. Okay, so we have the same formula basically. We would have same formula, but just adjust it to in terms of y. Okay, now so let's do a brief sketch of this again. There's our half parabola, x equals 4. Okay, so we're going to spin this about our x-axis. Okay, so that means we're going to have, when x is 4, y is going to be square root of 4, which is 2. So this is 2. So we'll integrate from 0 to 2. Then we'll have 2 pi. We're right up against our axis, so we have y. So when we go and figure out the height, the height, you have to first make sure your y equals square root of x. That's solved as x equals. So that means we would square both sides here. That would give us x equals y squared. Now, the tricky part to expressing this as x equals y squared is it's not just x equals y squared, because remember, we also have to factor in that we have this 4, right? So if we look at it if you look at it sideways, as if this was the x-axis, right? To get this height, the height, you're thinking about it like this, right? This is going to be your height now. So the way you get this height is if you do 4 minus y squared, or y squared minus 4. So you're going to subtract the 2. And you could verify that by just doing a simple plug-in. If you do y squared minus 4, you end up with negative results. 4 minus the y squared, that gives you the positive result here. Okay, so 4 minus y squared will be the height. And then you you do with respect to y. Okay, so we could pull out the 2 pi. You could distribute the y. So we have 4y minus y cubed. And now we could integrate this. All right, so we have integrated. So we would have, this would be 2y squared minus 1/4 y to the 4th. And then we would evaluate 2 to 0. Okay, so we plug in 2. We have 2 squared minus 1/4 2 to the 4th minus 2 0 squared minus 1/4 0 to the 4th. But now 0 squared and 0 to the 4th, that's all 0. So we only need to worry about the beginning part. So we have 2 pi. 2 squared is 4, times 2 is 8. 2 to the 4th is 16. 1/4 of 16 would be 4. 8 minus 4 is 4. 4 times 2 pi, that would be 8 pi. Okay, and that would be the final answer. So, to summarize for the shell method, these are the general steps, right? You want to draw the region, sketch the line segment across where it's going to be revolving around, label your height, your length, your distance from the axis of revolution, right, for your radius. Find the limits of integration, right? You want to figure out what the limits of integration are. And then integrate 2 pi r h with respect to the thickness variable, x or y. And then you would find the volume using the shell method. Okay, any questions, just write me an email. Or bring it up during class. All right, have a good day, have a good night. See you soon.